What is linear programming? A mathematical technique for maximizing or minimizing a linear function of several variables such as output or cost. Definition of terms. Objective function, the maximization or minimization of some quantity. Constraints, limit the degree to which the objective can be pursued. Feasible region, satisfy all the problem's constraints. Optimal solution, a feasible solution that results in the largest possible objective function value when maximizing. Graphical solution method can be used to solve a linear program with two variables. Linear function are functions in which each variable appears in a separate term raised to the first power and is multiplied by a constraint. Linear constraints are linear functions that are restricted to be less than or equal to, or greater than or equal to a constant. Problem formulation is the process of translating a verbal statement of a problem into a mathematical statement. Now, how to solve a linear programming problem? First step, understand the problem thoroughly. Dimensions LTD makes two products, tables and chairs, which must be processed through assembly and finishing department. Assembly has 60 hours available per week. Finishing can handle up to 48 hours of work a week. Manufacturing one table requires 4 hours in assembly and 2 hours in finishing. Each chair requires 2 hours in assembly and 4 hours in finishing. And profit is $8 per table and $6 per chair. How many tables and chairs must be produced to maximize profit? The problem is asking how many tables and chairs must be produced to maximize profit. Therefore, let x be equals to the numbers of tables and y equal to the number of chairs. Second step, describe the objective function. Let's go back to our problem. Dimensions Ltd makes two products, tables and chairs, which must be processed through assembly and finishing department. Assembly has 60 hours available per week. Finishing can handle up to 40 hours of work a week. Manufacturing one table requires 4 hours in assembly and 2 hours in finishing. Each chair requires 2 hours in assembly and 4 hours in finishing. If profit is $8 per table and $6 per chair, how many tables and chairs must be produced to maximize profit? The objective function of the problem is maximization of profit. Therefore, 8x plus 6y is equals to the maximization of profit. Third step, describe each constraints. It is said in the problem that assembly has 60 hours available per week. Finishing can handle up to 48 hours of work a week. Manufacturing one table requires 4 hours in assembly and 2 hours in finishing. Each chair requires 2 hours in assembly and 4 hours in finishing. To make it easier to identify the constraints, let us make a table. Therefore, 4x plus 4y is less than or equal to 60. 2x plus 4y is less than or equal to 48. X is greater than or equal to 0, and y is greater than or equal to 0, because the number of tables should always be positive in order to maximize profit. Graph constraints. Fifth step, then identify the visible region and its extreme points. Sixth step, substitute the coordinates of the extreme points to the objective function formula to find out how many tables and chairs should be produced to maximize profit. Therefore, for point A, 8 times 0 plus 6 times 0 is equals to $0. For point B, 8 times 0 plus 6 times 12 is equals to $72. For point C, 8 times 12 plus 6 times 6 is equals to $132. For point D, 8 times 15 plus 6 times 0 is equals to $120. Seventh step, decision making. Since point C has the largest amount of profit, dimensions LTD must produce 12 numbers of tables and 6 numbers of chairs in order to maximize profit amounting to $130. That ends our tutorial for linear programming. Thank you for watching.